Welcome to the next episode of our video series, Setting Up a Web Server in AlmaLinux 9.2 on Windows 11, a step-by-step guide. In this volume, we're going to dive into the world of SSL certificates and test HTTPS services on our web server using self-signed certificates. A self-signed certificate is a nifty SSL certificate generated with the OpenSSL command. It's particularly useful for internal testing and isn't meant for public use. But that's not all. We're taking it a step further. We're also going to test a basic website with 3 informative features of the web server. Server status: this feature provides real-time information about the server's performance and current connections. Server info: get detailed server configuration and module information with this feature. PHP info: learn all there is to know about your PHP environment. To spice things up, we're going to test our website on the server itself as a local host and also over an SSH tunnel through VNC service. But wait, there's more. In this video, we'll guide you through the process of installing the mod_SSL module for the Apache HTTPD web server. So, stay tuned for a step-by-step journey into securing and enhancing your web server with SSL certificates and exploring the fantastic features it has to offer. Let's get started. We'll begin by checking whether the mod_SSL module is already installed on your system. If it's absent, we'll guide you through the process of installing it using the DNF package manager. Next, we'll create a directory named SSL at /etc/httpd/ and generate a self-signed certificate using the OpenSSL command. The command is used to generate a self-signed SSL certificate using the OpenSSL tool. Let's break down each part of the command. 1. OpenSSL. This is the command to invoke the OpenSSL tool, a widely used open-source software library that provides support for secure communications via SSL/TLS, secure sockets layer/transport layer security, protocols. 2. REQ. This part of the command tells OpenSSL that we want to create a new certificate request. 3. X509. This option specifies that we want to create a self-signed certificate, as opposed to a certificate signing request, CSR, that would be sent to a certificate authority, CA, for signing. 4. Nodes. This option tells OpenSSL not to encrypt the private key. In this case, the private key will be generated without a passphrase, which can be useful for automated systems and services that need to access the key without user interaction. However, it's less secure than using a passphrase-protected key. 5. Days 365. This option sets the validity period for the certificate in days. In this case, the certificate will be valid for 365 days, 1 year. You can adjust this value to set the validity period as needed. 6. New key RSA 2048. This option generates a new RSA private key with a length of 2048 bits. RSA is a widely used asymmetric encryption algorithm for SSL certificates. You can change the key length by modifying the number after RSA, example, RSA 4096 for a 4096-bit key. 7. Keyout/etc/httpd/ssl/apache.key. This specifies the path and file name where the private key will be saved. In this case, it's being saved as apache.key in the /etc/httpd/ssl/ directory. Make sure you have the necessary permissions to write to this location. 8. Out/etc/httpd/ssl/apache.crt. This specifies the path and file name where the self-signed certificate will be saved. It's being saved as apache.crt in the same directory as the private key. When you run this command, OpenSSL will prompt you to provide information for the certificate, such as the common name, CN, which is typically the domain name for which the certificate is intended. You'll need to fill in this information as part of the certificate generation process. Once the command is executed and you provide the necessary information, it will generate a self-signed SSL certificate, apache.crt, and its corresponding private key, apache.key, that can be used to secure a web server or other services that require SSL/TLS encryption. This self-signed certificate is suitable for testing and internal use but may not be trusted by web browsers unless you import it into your browser's trust store. For production use, it's recommended to obtain a certificate from a trusted certificate authority, CA. As you follow along, make sure to respond to the prompts as shown in the demonstration. Feel free to modify these steps to fit your specific needs. We'll add the certificate and key information to the /etc/httpd/confd/ssl.conf file. Then, we'll restart the HTTPD service to apply the changes. Using your browser from the host machine, we'll check web hosting via both HTTP and HTTPS protocols. Keep in mind that since the certificate is self-signed, your browser might not accept it as a trusted source. However, for testing purposes, it's perfectly acceptable to proceed. We'll also guide you on how to check the certificate data and its validity. We'll repeat the testing and validation process, this time using VNC Viewer. We'll use the direct localhost and actual ports for this. Moving on, we'll create two files at /var/www/html/index.html and finfo.php. Once again, we'll use the browser to check these files. Finfo.php provides detailed information about your PHP installation. We'll also show you where to find files for HTTP server access and errors. Now, we'll dive into developing the code for server status and server info. Using VNC service, we'll check the server info, server status, and finfo pages. And that's it. Thanks for tuning in to this video. We hope you found it helpful and informative. If you have any questions or need further assistance, please don't hesitate to ask. Don't forget to like, subscribe, and hit that notification bell to stay updated with our web server setup series. We'll see you in the next episode.